Okay, so we're going to start section 2.2. We're going to start with a couple of definitions, and so let me switch. Uh-oh, come on. I'm going to switch over here and type those up for you. All right, the first one is a prime number. Of more than one factor. Sorry, I can't read. All right, so two definitions. Prime number has only two factors. One and itself means it's divisible or can be divided by one and by itself. The other one is a composite number, and composite numbers have a different definition, and that means that they're kind of the opposite of what a prime number is. And so meaning that they can be, that number, composite number, can be divided by one, itself, and at least one other factor, okay? And technically it's actually two numbers because two numbers multiplied together made that other number. So let's look at an example. There's actually one last definition that I want to present to you, and it says one, the number one, is neither prime nor composite. Because one, how did we get one? 1 times 1. And so a prime number has two factors, but 1 times 1 is the same number twice, and so technically it doesn't have two factors, and so that's why the number 1 cannot be prime. It's also not composite because it doesn't have more than one factor at all. Okay, so those are our three definitions that we need to hang on to for this lesson. So some prime numbers. Prime numbers could be 2, 3, 5, 7, 11, 13, 17, and 19. There are others. There are plenty others. But I want you to see that, how did I get 2? Well, 1 times 2 is the only way that I got 2. So that means that the factors of 2 are 1 and 2 because they both go evenly, divide evenly into 2. Okay? And so if I was asking you to write all of the factors of 2, this would be my answer list. You list them in order from smallest to largest and separate them by a comma. Okay? So let's try 13. 13, the only way that I can get 13 is by multiplying 1 times 13. There is no other way using whole numbers to find the number 13. And so the factors for 13 are 1 and 13. Remember that we start from smallest, which is the 1, separated by a comma, and write 13. So these right here are factors. Okay. This list up here are all prime numbers because they will only have two factors. The next list is just a couple of examples. So 4, 6, 8, 9, 10, 12, 14, 15, 16, 18, and this keeps going. There are plenty. So if we pick out one somewhere right here, okay, and I show you, how did I get 12? Well, 1 times 12, and 2 times 6, and 3 times 4. And I want you to see that I kind of went through the list in order. I started with 1 times what gave me 12, and 2 times what gave me 12, and 3 times what gave me 12. And I want you to know that not every number is going to go into 12, but we've listed the ones that we have come to that work. So for example, if I went to 4, well, 4 times 3, I already wrote that one. The next number would be 5. Well, 5 doesn't go into 12, so I would not write that number. So once I start repeating them, which I did, the 3 and the 4, I know that I'm kind of out of options and I'm done finding all of my numbers. So when I write out the factors of 12, I would write 1, 2, 3, 4, 6, and 12. These numbers divide evenly into 12. and I listed them out from smallest to largest, separating them by a comma. So 12 is a composite number because it has more than one or more than two factors, and these are the factors. Okay. All right, moving right along. Prime factorization is the next thing that we're going to work on. Prime factorization sounds awful, but it's really not that bad. So the first thing that we're going to do is we're going to start with a number. And the number that we're starting with is 20. And what we want to do is we're going to kind of branch out because there are two numbers, right, that you're going to multiply to give me 20. Because 20 is not prime. So we're going to break this down and we're going to create something that looks kind of like a tree. And so how did I get 20? Well, I got 1 times 20. I also got, let's see, 4 times 5, 10 times 2. So you could kind of go in multiple ways. My first number that came to mind was 4 times 5. So 4 and 5. At this point, I asked myself, is 4 prime? And the answer is no, because 1 times 4 gave me 4, but 2 times 2 also gave me 4. So there's more than 2 factors for 4. So this guy's going to have to break apart again. But 5, is 5 prime? It is, because the only way that I got 5 is by multiplying 1 times 5. And so since it's prime, we are going to circle it because we are not moving forward with that guy anymore. So if I go back to my 4, how did I get 4? 1 times 4 and 2 times 2. And the reason that I did the 2's was because I knew if I wrote 1 and 4, I didn't really get rid of the 4. I didn't change it at all, and I'd have to break it down again. And so now my question to myself is 2 a prime number? Yes, because the only way I can get 2 is 1 times 2, and it only has 2 factors. And so I have no other numbers to break apart and continue on. And so I am done with this. I have broken this down, and I have found my factors that are prime. And so what is my list? My list is 2 times 5 is how I got 20. And you could write this in another way. You could actually see that you have 2 of these, and you could write 2. I have the number 2, and I have 2 of them, and I have my 5. So both of these are the same thing. So, for example, the 2 that you see is this number, the number that you see, and how many times you see it is how I got this little exponent number. Okay, so both of these boxed in answers, 2.2.5, or 2, the dot means times, or 2 squared times 5 are both the correct answers. Let's do one more of those, and let's do 32. So I'm looking for prime factorization of 32. And so I'm going to break this apart and multiply. And so you're asking yourself, what 2 things multiply, together to give you 32? And you would find 8 and 4. And you could actually do 16 and 2 if you wanted to. But I chose 8 and 4 because I want you to see that sometimes both sides of this little tree are going to have to break apart. So 8 is not prime and 4 is also not prime. So we're not circling anything, but we are breaking both of these apart. And so I've already done a 4, and I know that I can actually break those down into 2's, and I already know that those are both prime, so I'm going to stop on that side. But now I'm back over here for the 8, and I'm asking myself, what 2 things multiply together to give me 8? And I find 2 and 4. Well, I already know that 2 is prime, but 4 is not. And so I'm going to go ahead and break this 4 down once again and find another 2 times 2. And again, I find that all of the 2's are prime, and I'm now done. I've broken down everything that I can, and so my answer could be 2 times 2 times 2 times 2 times 2, or it could be the number that I see, 2, and how many times do I see it? I see it 1, 2, 3, 4, 5 times, and so it could be 2 to the 5th power. So both of these are correct answers. Okay. I want you to see that problem that we worked just a few seconds ago, I'm going to kind of give you a little vocabulary term here. This guy right here they are, I mean, I want you to see that they are both the same. 2 times 2 times 5 is 2 squared times 5. It's the same thing. But this bottom one is actually called exponential notation. And exponential meaning exponent. And so you're writing the problem answer with an exponent. Exponential meaning exponent. And so if your homework ever asks you for that, that is what you need to make sure that you are doing. All right, we're going to move into the last little section here. And I need you to know 2 things before we finish with this. And the first one is comparing fractions, and the second one is simplifying fractions. And so we're almost done with your second lesson. When you compare fractions, we're going to use a couple of symbols, and those symbols are these guys right here. And so I want you to see that this first one is greater than. Okay, the second one over here is less than, and the last one is equal to. Now, how can I help you remember which one of these is which, right? They're hard to remember, and so I'm going to take this guy in the middle right here. And so if I kind of rewrite this, I want you to see that I could write the word less, because this guy sort of, if it was tilted just a little bit more, could be an L. Now, if you took the other one and wrote it, you would see that that does not make an L if you wrote it in any direction, wider or skinnier. And so we're just going to know that one is less, that fits like an L. The other one is not less, and it's going to be considered greater than. So we're going to put one of these 3 symbols, this, or this, inside between these 2 fractions. And so let's go ahead and look at this right here. All right. So a couple of different things to think about. It is very hard to compare fractions if they do not have the same denominator, because we're not talking about the same measurement, basically. So I'm going to teach you kind of a shortcut way to be able to figure out which one's bigger. And for this, the rule is to start at the bottom. Bottom to top is how you solve these, to top. Is how you're going to solve these. So we're going to start at the bottom over here and work our way to the top and put an answer. We're going to start from our bottom over here, work our way to the top, and put an answer over here. And so what I mean is I'm going to multiply 4 times 5 and I find 20. And I multiply 20 times 1 and I find 20. And so the 2 things that I'm comparing are 20 and 20. And so what symbol is going to go in between these? Well, 20 is the same as 20, and so the answer that goes between these is an equal sign. And so that's my final answer for this problem. Okay, let's try another one. The second one is going to be 2/3 and 4/9. Remember, the rule is bottom to top, and so I multiply 4 times 3 and I get 12. And bottom to top over here, I multiply 9 times 2 and I get 18. And so 18 and 12, I'm comparing those 2 numbers that you see. And remember, I could know the name of the symbol and not know how to use it correctly. And so I want to show you that these 2 symbols, if you put little teeth in here and an eye, I want this mouth to eat the bigger number. So if I put this symbol in there, it would eat the 12, right? Because the mouth opens towards the 12 to eat it. And so that's not going to work for us because we know that 18 is bigger. So I'm going to put this symbol in it, imagining that there are little teeth all in here, and that is going to eat the bigger number. And so the symbol that I put in here is going to be my final answer. This symbol is greater. And so if I read this from left to right, I say 18 is greater than 12. And so that makes sense for us. So the greater than symbol is our final answer. All right, the last little part we're going to do is simplifying. So simplify fractions. All right, to simplify a fraction, we start with a fraction. Okay, I have 4/10 or 4/10. And for us to simplify this, I'm finding a common number that goes evenly into the top number and into the bottom number. Well, 4 and 10 are both even numbers, so they can both be divided by 2. I'm going to start there. If I can divide by 2 again in a second, then I will, but if not, then I'm going to have my final answer. So 2 goes into 4 2 times, and 2 goes into 10 5 times. So now I have 2 over 5, or 2/5, and 2 is prime and 5 is prime, so I can't divide 2 and 5 by a common number anymore, so this is going to be my simplified final answer. Okay, let's try another one. Let's try a little bit bigger of a fraction. I'm going to try 32 over 48. All right, so first of all, there's probably a pretty big number that I can divide into both of these, but I don't know what it is right now. So I'm going to start small. And so I'm going to say they're both even because this ends with a 2 and this one's an 8, so they're both even. So I'm going to divide any even numbers by 2. And so when I do that, 2 goes into 32, I get 16. 48 divided by 2 gives me 24. Well, 16 and 24 are both even numbers, so I'm going to, again, divide by 2. 2 goes into 16 8 times. 2 goes into 24 12 times. 8 and 12 are both even numbers, so I'm going to divide by 2. So 2 goes into 8 4 times, and 2 goes into 12 6 times. Well, 4 and 6 are also both even, so I'm going to divide by 2 again. And so this time what I find is 2 goes into 4 2 times, good grief, 2 times, and 2 goes into 6 3 times. And so I ended up with a fraction that is 2 over 3. Well, 2 and 3 are both prime numbers, and it does not look like I can break this down any further. And so this will be my final answer. Now, looking back, I can see that I ended up with 16 is the number that would have gone into both of those evenly. So if I divided 32 by 16, I would get 2. If I divided 48 by 16, I would get 3. So does that matter? Could you have picked a huge number and gotten it right off? Sure. Did you need to divide by 2 to get the right answer? For some of us, yes. And so it doesn't matter what the steps are that got you there. It just matters that you arrived at the right answer. You're going to keep dividing as many times as you can until you end up with a final answer that cannot be divided by the same number. That's how you know that you're done. Okay. All right, so that's all we have for this 2.2 homework, or 2.2 lecture video. You will be moving on to your try on your own problems. You can find those in Moodle, and then bring them to class, and we will do some group work and then start on your homework.